right, so I guess we'll get started. You, Mike?
Yeah.
So really pleased to see Mohan from IBM here today. I've known him for a long time, like since I was a graduate student and interviewed at Almaden. He's like one of these people who's had a tremendous amount of influence on the field. Probably one of the most influential database researchers. Everybody in systems basically has to read his papers and figure them out. And they're not short, they're not simple. But he's also the kind of person who's like been very supportive of like graduate students throughout the ages. So I would send him my papers, he would send me comments back, what are you thinking? So he's been one of my favorite IBMers forever. He is a fellow of everything, including IBM, which is a very significant thing. And so he's going to come and tell us the story about big data and why it's like really important and why it's a brand new thing that nobody ever thought of before.
That's
so
right.
Thank you very much.
And it's going to solve the world hunger problem.
Exactly. Exactly.
Thank you very much. It gives me great pleasure to be here. For a long time, Mike in particular has been threatening to invite me over, and finally it happened. Like he said, I've known him forever, and he has been an IBMer. He has been a colleague, he has been a promoter of Aries and all that for a long time while he was at Wisconsin and later on also. Along those lines, Sharad is my academic sibling, if you know what that means. We have a common PhD advisor, actually two probably. Yeah, both advisors were the same, Avi Silberschatz and Don Fussell. Of course, we all have been in the database area for a long time, especially the two of us compared to this younger person here. And even Nalini I know for quite a while, since she was originally in the Bay Area working for HP Labs. So the one person that I've known even longer than you guys that's not here is Ramesh Jain. He was in UT Austin as a postdoc coming in the summer of 1978. I came there in fall of 77, so I'm really old, to do my PhD. And so Ramesh, unfortunately, is in India right now, so he's coming back only tomorrow, apparently. Anyway, so this presentation, as the slide says, you can find that location. It's actually a Facebook document, a note. Even if you're not on Facebook, you should be able to access it. And I prefer that if you refer to this presentation, just give that URL, because as I revise the presentation, the actual link that's on that note, which points to the PPT, will keep changing. Unfortunately, they don't allow in-place updating of a previous version with the new version while keeping the URL the same, whether it's Google Docs or wherever I stick it. But unfortunately, whatever I chose to use was not accessible in China. And here I am giving this talk and trying to tell people, go pick it up from here, there, and all that. And none of the places that I used was normally accessible in China, whether it's Google or Facebook or whatever. So this presentation I originally prepared when I was asked to give a keynote speech at the French database conference last year. But in fact, just before that, at the last minute, the BERT people, the Business Intelligence and Real-Time Enterprise, which is a workshop attached to VLBB, asked me to give a keynote. I wound up giving it, and more recently I've given it in Germany. So the presentation has evolved since I originally gave it, and I'm about to give it in the the Italian database conference in June. So the German one was in March in Hamburg. Oh, there's no remote. Okay. So this stuff, I'll assume you all know. Currently it's very hot. Even the popular press is into all this. There was a cover story a few years ago in The Economist. Everybody wants to be part of this, just in case it really takes off and there's lots of money to be made. So it's not just little companies and VCs and such, but big companies as well as academia and so on are also big time into it. And it's not that analytics hasn't been there. We used to have SPSS, SAS and such companies and their products being used. But typically these required people with fancy degrees in statistics to be able to use them, and they were not easy to use. So the whole point of the recent era is to make it usable by mere mortals who are more experts in specific domains rather than being statisticians and so on. Of course, this thing about the initial euphoria. I mean, for those of you who know about the Gartner hype curve, we are now at the peak of this, hype, and more or less reality has started setting in, and this is why you will see some weird things that you'll find in the subsequent slides and so on. As companies try to go public and all that is when you get to see some real numbers as opposed to their hype about how well they are doing, who is using their product, blah, blah, blah. I'm sure you know about all this, words starting with V, the 4 V's, or some people even talk about 5 V's. And then what else? Yeah, so in terms of models of people behavior and so on, that again has been there for a long time, except that they were handcrafted models, whereas now people are trying to use machine learning. And in fact, the other day I was at a Bay Area meetup where deep learning was the topic. So essentially, what do you call them?
Neural nets.
Your neural nets. This is a new terminology apparently. I didn't even realize, instead of saying neural nets, they are now calling it deep learning. And so it's even dumber than what you might think is needed to do certain things. And they were showing all sorts of, these were like 4 or 5 different guys from different organizations that were at this panel that T.M. Ravi of the Hive had organized. And so there's quite a bit of interest in revisiting lots of things that might have been discarded in the past and such to see whether, because of the scale and the compute power, cheap compute power that's available, you can now afford to do certain things that might have been computationally found to be too expensive or whatever in the past. The other major realization is that, like throwing the baby with the bathwater kind of thing, where the Google guys and people of their ilk in the Web 2.0 companies that had decided low-level geeks-oriented kind of APIs are good enough. All the 3 decades of, sorry, let me shut this off. 3 decades of mantra that had been taught about the goodness that comes from high-level query languages and such, you don't need those things because they're primarily trying to solve a very specific problem with MapReduce or whatever the thing was. But now when companies are trying to make money off of this big data stuff, and they are not just trying to cater to the needs of the Web 2.0 kind of companies, they are then beginning to realize, oh shucks, what might have been good for the Web 2.0 crowd where you have, you and me kind of people. I don't even consider myself to be a geek, but let's for the time being think I'm a geek. But it's for the Joe Blow developer of Main Street America or wherever, right? Those guys are not particularly excited about having to code to low-level APIs, and that too APIs that are different for different systems and so on. So there's a whole lot of nonsense that's being, lapped up by techie people that are not necessarily okay for the general purpose kind of crowd. And so this is where now, the things that got thrown out are being slowly sucked back in with, SQL level kind of access and such being provided on top. Okay, so there are various types of applications that you can think about in the context of this big data arena. In particular, I have highlighted a couple of them, the first 2, because they relate to the kind of things that have been done at Almaden by the text analytics teams of Shiv Vaidyanathan, Raj Shekhar, and others, Yun Yao, and so on. And those, you'll see a little more detail on the first one. But then there's, you can come up with even more applications that could benefit from the big data technologies. And in fact, The Economist organized a meeting 3 years ago, I think, at the Santa Clara Convention Center for a 2-day session where they brought together all sorts of people from all across the globe. I was pretty amazed at the variety of people they had, including John Newsom, I think, the ex-mayor of San Francisco, who is the lieutenant governor of California, who was the first guy apparently, at least in city government kind of environment, to open up the stuff that's not, subject to privacy controls and so on about the functioning of the city government open data initiative. And so there were many, many such people that I didn't even think of when I thought about big data that were present at this meeting. And so it's incredible the variety of arenas in which big data technologies are being applied. And if you look at even something like this, where connecting information from the social media with your corporate databases, it turns out to be non-trivial. Look at my own Facebook name versus my LinkedIn ID versus my Twitter handle. SEEMOHAN is my Twitter handle, whereas on Facebook I go Mohan C. Mohan, whereas on LinkedIn I'm Mohan C. And how do I then connect all that to, let's say, the IBM corporate database where I'm represented as 820801, right? That's my employee ID. It's a non-trivial task to do this entity resolution across these different sources. And why do you want to do that? Because, you know, I go and bitch about my camera not working properly or whatever on Facebook, right? Now Sony wants to figure out who's this guy that's complaining bitterly. Let me see what I have in my corporate database about anything that relates to the purchase of this camera by this guy and what had happened subsequent to the purchase and all this kind of stuff. And so in order to do those sorts of things, you have to be able to relate these things. And so it's all this kind of stuff that you need to do. And then in the particular example given there, IBM's Almaden people were working with the SEC in relating how different organizations and people are related to one another. So one company may be a subsidiary of another company, one company may have a controlling interest in another company, somebody is an officer of one company but on the board of governors, board of directors of another company and things like that, you know. And then there may be even relationships like somebody is the spouse of somebody else who's got a controlling stake in a company which has conflicting interests with that first company. So all these sorts of things which might be buried in SEC filings but have to be extracted out if you are really trying to see if there's some sleazeball thing going on. Apparently, people even do things like, in one place they may say Robert Ames, in another place they say Bob Ames, just to hide the fact that it's the same person but is doing some conflicting things and they don't want too many people to know about. So even if the SEC filings have structured fields, a lot of stuff that may be more interesting is stashed away in text fields where unless you do text analytics, it's not easy to extract out some of the information. And what you also want to do is as you rummage through all the text, you are extracting out structured data and then you want to be able to query that structured data even as you are doing your ETL style processing, but now for text. Extract, transform, load type of thing that was traditionally done for structured data in data warehouses and such. Those sorts of things have to be adapted and be made to work. And also the question was, what's the intermediate representation as you are extracting structured data out of semi-structured or unstructured data, and how do you then query such things, and you know, and then do all that statistical and machine language kind of machine learning kind of modeling and so on. And then you are using it for all sorts of things like systemic risk management, wealth management, and so on. Okay, so this is just one example. So last year there were a couple of panels at VLDB and Sigma that I was a part of or was the moderator of. And in fact, Mike was on the panel at VLDB. And also in Northern California, we had a database day where I ran a panel where I posed these sorts of questions. Traditionally, all this MapReduce stuff, I don't know how many of you know the history of these two guys who came up with it, Jeff Dean and Sanjay Gamawat. They are from the Barbara Liskov School of Computer Science, which is the distributed systems, programming languages, and sort of transaction kind of people. Barbara, the second woman to get the Turing Award, for example, she has been in the my kind of space, but not quite, because these are distributed systems people who have sort of dabbled in database transaction thing, but not quite. So they look at things very differently than what me and Jim Gray and Mike and various other people. Sharad also, his PhD thesis was in concurrency control and such. We all have a different take on this kind of stuff, and so So they had a very specific goal when they did MapReduce, which was at any cost, meaning consuming all the resources that are there in this cluster, go off and try to minimize the time it takes to run a batch job, period. There was no attempt to run multiple jobs in parallel, no attempt to have a higher priority job coming in while a low priority job is doing its thing and then interrupting it and all this kind of stuff. They worried about failures because they were interested in using El Cheapo processors and locally attached disks, where the disks were not even industrial strength disks, because you and I are not paying Google and such guys for the services we get out of them, right? So, but we at the same time have all sorts of fancy expectations with respect to response time and such. So they are trying to do the best they can with the minimal amount of money to be spent. But it's not always the case that it's for technical reasons that they choose to go a certain route when it comes to what software they use and such. It's also for other reasons, which gets a lot of times forgotten. And that has to do with this ability to go tinker with the innards of the software if something doesn't work to their liking or they want to change the characteristic. And if they were to go with the DB2 or an Oracle or whatever, they don't have that level of control. So even if relational is okay, they will for the most part settle for something like MySQL where they have access to the source code. Okay? So this fact needs to be kept in mind because sometimes people go around claiming, oh, all Web 2.0 companies only use NoSQL system. Total nonsense. In fact, Facebook has tons of people that are working on MySQL, even as committers and so on, as well as developers who use it to store gobs and gobs of data. So there are different types of systems being used even within one organization like Facebook. It's not the case that it's all just NoSQL. The other point that keeps coming up is if the geeks of Web 2.0 world can handle certain weirdnesses with all these products, is that a sign that the rest of the world will be able to tolerate it? And this was a big mistake, in my opinion, that many of the people made, and to a large extent, the academicians also got a little carried away with this Web 2.0 crowd choosing to do certain things, and then they thought, the whole world needs to adopt this, adapt this, and so on. We'll discuss all this in greater detail as time goes on, but it's also the case that did the focus on scale, parallelism, and commodity everything warrant ignoring decades-long, well-understood design principles relating to power of high-level specs, usefulness of standards, expectations from programmers, and so on. So if you look at many of these NoSQL kind of systems, before they began to realize the errors of their ways, even the join had to be performed in an application. This is like a giant leap backwards for mankind compared to, what existed before the relational era, right? And we have gone through all this. I mean, even if we personally, I have, but even if we haven't personally gone through, that's not a reason enough for us to again have to repeat history, okay? So I'm going to now bug this mic about the other mic. Mike Stonebreaker, who just gave who got the Turing Award, of course. Thanks, congratulations to him. I supported it, actually. But he also, at the same time, made this statement 10 years ago in a paper for which he actually gave the 10-year best, he got the 10-year best paper award at this year's ICDE, and he gave a keynote and all that. He said, oh, one size doesn't fit all. Now, this is being taken as, oh, hallelujah, now we can go develop for every Mickey Mouse difference in functionality yet another piece of middleware. So let 1,000 flowers bloom kind of chaos. And if you don't think there is enough chaos, wait till you see some picture I show. So even in companies like Facebook and Twitter and such, and I've given, by the way, variations of this talk in those two organizations, and Cloudera and other guys are bugging me to go give also. They cannot, from a pure software engineering viewpoint, sustain, even with all the resources that they have and the smart people they have and all that, keep enhancing these gazillion things that they crank out, even if the open source community adopts it, this, that, okay? And so I raised the question with even Jay Parikh, who is the VP of Infrastructure at Facebook, who was a keynote speaker at the VLDB in Riva del Garda. How do you guys decide what the budget is that your IT shop should have? compared to the overall revenue and all that. How does Mark Zuckerberg decide, how much money is worth spending on all this IT stuff? And even then, what do you do when your guys, go for greener pastures and they develop something quick and dirty, don't document very well, they do design on the fly as they code and so on. And what happens to this next set of people, fresh kids who come in, who have to now take over this thing and make sense of this nonsense? Then the tendency a lot of times is, rather than figure out what this one does, how it does it, and to tweak it to do something slightly different, let me just go off the deep end again and start something from scratch and build a brand new system. This, of course, it will take more time to do that too, right? So it's not like a solution to say that every slight variation in functionality, just because of this mantra of one size doesn't fit all, we should now go and do a new thing. And also this business of everybody thinking, oh, if your paper's algorithm doesn't deal with 1,000 servers or more, it's worthless. This has become like a fashion statement of the day. Who really wants to manage 1,000 servers? It's not an easy thing to maintain and update the operating system with bug fixes and security holes and all this kind of stuff. So yeah, I mean, it is true that the less powerful processors are proportionately cheaper than the more powerful processors, but by that token also the failures increase the more moving parts you have, so to speak. And so in addition to that, all the talk of petabyte databases, it turns out even in these Web 2.0 companies is not as common as you would like to believe. They have any number of smaller databases than the petabyte size databases. Even in India, Airtel has a petabyte database, but that doesn't mean every telecom company in India necessarily has a petabyte database. And also you have to distinguish between historical data versus current, in production, subject to modification kind of data. And so the bottom line is that as the classical DBMS kind of features get introduced, because they were erroneously thrown out to begin with, and these systems evolve in a certain way, at the end of it, are these systems going to be really as dramatically different compared to traditional parallel database systems, a la Teradata or DB2 Parallel Edition or Nonstop SQL, whatever they call it, MP something. And then the question, and also the other point is, market shakeout is bound to happen, and who's going to be left standing. And if you happen to choose, rightly or wrongly, a particular system and it doesn't survive this shakeout, and that system didn't use standard APIs, guess what? You now have a problem in your hands. You have to rewrite your app to now move your thing to a different system, or even if it's an open source system and hence you have still access to that thing, you now have to worry about fixing the bugs and this and that that are bound to be there. It's not like any of these things is 100% bug free. Okay, so now let's see what the reality is in terms of hype about all these companies and so on. So Allied Market Research said Hadoop market, which includes hardware, software, and services, was about 2 billion in 2013. This is Hadoop, this is not big data, okay? Yeah, I mean, you don't have to believe in the absolute numbers, it's all order of magnitude that's important. So they claimed by 2020 it will be like 50 billion, which is like a pretty good CAGR of 58%. IDC, for the bigger thing, big data, technology and services, though presumably that doesn't include necessarily the hardware and hardware part of it, 9.8 billion in 2012, and they think it's going to go to 32 billion by 2017. Now, Hortonworks is the only one of the big three Hadoop companies that has gone public. So it was revealing to look through the SEC filing that they made back in November. They actually went public in December. And that's where you get some reality checks. In spite of all the hype, in spite of the fact that they made $33 million, $41 million by September 2014, in the 12 months ending in September 2014, guess what the profit was? Minus $101 million. Now, when they IPO'd at $16, that amounted to a valuation of $1 billion. So for a company that lost $100 million, some people, what they were smoking and all that, don't ask me, went and bought the shares and made this one. If you think that's bad, look at this one. The one that hasn't yet gone public, another Mike, used to be the CEO, he's now the Chief Strategy Officer. I actually heard him give a talk recently, and it was very revealing. Actually, he was pretty open, cool guy. He was also the same Mike Stonebreaker student. Last year, a year ago, they had a valuation of $4.2 billion. How did the rest of the world figure out this one, even though they are not public? Because Intel invested, I think, something like 700 million or so, and they got an 18% stake ownership in the company. And so then people compute from that what that amounts to in terms of overall valuation of the company. Now, Mike speculated that this had to do with Intel wanting to make sure nobody else acquires this company. They got a board seat. I was actually pretty surprised he said all this in public. So we still don't, okay, and the other thing he mentioned was that they had a revenue of $100 million. Of course, he didn't breathe a word about what their profit situation was. They're not required to report anything because they haven't filed for IPO. IDC, just for storage, estimated that last year about $6 billion were related, were ones that had to do with big data. Mo Adrian, he's a very famous guy in the Gartner database analyst community. He says, he gives these quarterly seminars, that in February 2015 when he gave the seminar, compared to the previous quarter, the interest in Hadoop was not rising as rapidly as he had seen it before. Okay? Okay, so some more quotes. You have to be always careful when people tell you, oh, XYZ company is, and XYZ is a big company, bank, insurance company, whatever, is using my technology. Unless you ask and probe really, you won't know whether some guys who are also the fringe guys, like I'm a fringe guy in IBM, right? I'm a research guy, I'm not a product guy. Whether it's some fringe guys, meaning ad tech team in that organization that's kicking their tires on this, you know, brand new shiny technology, or is it actually the real people, meaning they're mainstream IT guys or mainstream business type people that are using the technology. So it turns out lots of people are trying out these big data technologies, but many a time they're having a hard time demonstrating quantifiable value out of it for the business types, for the C-suite guys to sign off on in production deploying it. Or the experimentation is done without worrying about privacy and various things that you need to worry about in a production way, governance and such things. Existence of tools that make monitoring and such things feasible. See, one of the big issues with shiny new technology is that you and I might get excited as techies looking at algorithms and this and that. There's a whole lot of ecosystem stuff that goes around it that all needs to be there before you can really use it in a practical sense. It was very revealing when Daniel Abadi gave a keynote speech at EDBT 2 years ago in Italy. He was talking about his experience after starting this Adapt company, where he tried to commercialize his research work. And he said, whatever he thought as an academician turned out to be pretty wrong by the time he got involved in the company, because what determined what the company did was not so much based on abstract notions of what is the right thing to do, what the average case scenario is, blah, 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 but it was more based on who is willing to even try out my software. Whatever their requirement becomes the predominant requirement. Because they're so desperate. And then on top of it, he found data loading was the most painful thing. None of this other fancy stuff that you and I might think is the most technically interesting stuff.
So is that true even when you're old enough to know this, I think. When the relational technology came around,
yeah, of course.
Was that still the case?
Yeah, I mean, there weren't that many tools available, like 4GLs and so on, were not there. But the saving grace there was, because of the introduction of the SQL standard, which happened a little bit after IBM and Oracle introduced their products, some of the tools that were developed on top could more easily be ported from one vendor product to another, whereas here the issue is each of them having their own APIs, which are pretty different, MongoDB versus something else, right? Makes it so much harder. And so now the tool providers, first of all, have to come into existence, and then they have to figure out who is likely to be there in the long haul and bet as to which ones they try to cater to as the underlying platform. So all of this makes the whole thing even more problematic than it was in the era of, but even before relational, even though there was no real standard, DBTG standard was there, but not too many network data model, but not too many systems implemented it. IMS became a de facto standard. The DL1 language of IMS became a de facto standard, and so there were some of these German companies and such, ADR and so on, that tended to then support it, because those were the days when IBM's things became the de facto standard. Yeah, it's also a question of how much adoption happens and how rapidly it happens. But today, the bigger issue is there are any number of startups in the cloud arena as well as in this kind of arena are very quickly picking up stuff. So the adoption is very rapid, but by the same token, the death is also very rapid of many of these kinds of fly-by-night startups and so on. So, and sometimes the startup people don't think a whole lot about various issues because they are trying to find a quick and dirty way of producing something, exciting some people, either go public and then laugh their way to the bank, or get acquired by somebody, and then the problem is in the laps of this acquired company, be it IBM or whoever, right? SAP, Oracle, whoever, then to deal with all the mess that's been created where they didn't address many of the, even Uber and so on, there's so many unresolved issues, right? Insurance, even such things have become a big factor with Uber. You and I might get excited, but we are getting cheap ways of getting from here to there. But when you really look at it as a full-blown business, there are so many things that need to be figured out. The other point, which keeps getting ignored, that these Gartner guys have emphasized, yeah, it may be fine and dandy to say, I don't want to pay IBM or Oracle or Microsoft money to buy their products. I'm going to go adopt this open source thing. And people think by doing that, they've saved a lot of money. The point that's being made here is you actually shifted the money you spend from paying license fees to somebody to paying top dollar for this very scarce resources that are knowledgeable to deal with many of these open source things because of various factors, right? They don't have proper documentation, you can't appeal to anybody to get necessarily any support, or their APIs are so unique, not too many people in the world are aware of them, and the skills availability is not there and such. And people also get easily swayed from being moved from one company to another, so retention is a problem, all sorts of things like that. So this also is the case that they are not sure about the value of these efforts, and so if you can't demonstrate, that also becomes a problem. Okay, so I'll let you guys go read some of these things yourself, but one of the things that's become popular, by the way, is this notion of data lakes. Unlike traditional data warehouse where data gets munched on and this and that and cleansed and so on and made to look fairly clean by the time it gets stored and made available for querying and such. People are now saying, oh, I don't know what I might do with some of the data that's being collected, and so I don't know what kind of analytics might be interesting to run, so I don't know as a result exactly how to cleanse the data or how to store it and what sort of indexes to define and things like that. So let's create this thing called data lakes where we just dump all the data in its raw form, right? And then as needed, we'll figure out how to then go and extract stuff out of it and use it for a certain purpose and so on. Turns out, while it sounds good and a bunch of people are excited about this notion, it has its problems too because there's no governance, there's no semantics associated with the data. So it's very hard to, when you actually want to use it, be able to interpret it. There isn't any, what do you call it, this history tracking, provenance.
Okay.
So, so tracking of the provenance of the data, who produced it, who moved it from here to there, and if they did transform it, to, why did they do it, and what was the logic behind it. The sorts of things that go around the traditional way of doing data warehouses is lacking in this world. And so they are now, as a result, saying what you might wind up with is a data swamp. And maybe you'll get drowned in it if you put your leg in it to test the waters or whatever. So this notion of semantics and all that is all messed up too.
Mohan,
yeah.
So is there a lot of activity in the commercial sector in this data lake?
Yeah. I mean, in fact, even the MIT guys are doing something in this space, let alone commercial. I'm just saying, this is something that has become like a buzz phrase, this notion of data lakes, because people say, one of the bad things about relational systems was that this business of data loading, right? You produce the data in some weird form, and then you had to put it into CSV, this or that, or whatever, and then I had to load it, and that itself was time consuming, and especially if the data is really large, this becomes like a negative thing. And also, now you might wind up actually, depending on what you did with that data, if you created indexes, this, that, it could blow up quite a bit because the metadata or the ancillary data, auxiliary data, like in the form of indexes and such, could eat up quite a bit. It's a well-known thing for text data, for example. If you did full text indexing, the index size could be quite a bit more than the original data size. Whereas with this, you are keeping it in the raw form, you are sticking it in all these El Cheapo drives, which are typically locally attached consumer-grade disks that you and I use in our mobile phones or whatever, right? I mean, laptops and such, not traditional fast-spinning, high-reliability drives of the data center, traditional data center, whereas all these Amazon and all these guys are using these cheapo ones. There are different kinds of workloads. Gartner at least defines small, medium, and large to be of this kind. 40 terabyte is considered large. There are many projects. I have yours also mentioned there. All across the globe. National University of Singapore, in Berlin, there is a Berlin Big Data Center. Also in between Leipzig and Dresden, they have a joint thing. And then, of course, you have at UC Berkeley, this Institute for Data Science. Just day before yesterday, I was at Stanford. Finally, Stanford, which has been lagging behind, has initiated this big data initiative with even Infosys as one of the founding members and some insurance company. They have 2 classes of membership. And in Berlin, the guys are very excited because they had this joint project across the 3 universities, Technical University of Berlin, Humboldt University, and the Hasso-Plattner Institute in Potsdam, which is just outside Berlin, that their Stratosphere project, which became Apache Flink, has graduated to a top-level project, and there's even a company now, Data Artisans, that's been formed to work on the commercial side of it. I even visited those guys a few weeks ago. And then, of course, at MIT, you have the Big Data Initiative, which Intel, I think, is a sponsor of. And in Almaden, of course, we have System T, System ML. And just yesterday, I found out Fatma had been here and talked about Big SQL, so I don't need to talk about that. And then there is this 3 university thing involving University of Washington, NYU, and Berkeley. That's called the, whatever the name is. There's some name for this. It's jointly funded by some organizations. Okay, so if you want, you can offline go look at it. By the way, I mean, there are references to lots of papers and this and that in that original URL I gave you. And in terms of funding, both for the research as well as education, there are various sources, including the Gordon Betty. Yeah, so those are the guys who are sponsoring the 3 university thing. UW and Berkeley and NYU, funded by Gordon and Betty Moore and the Sloan Foundations. And then there are courses. I was asked to speak a couple of years ago in the summer by Juliana Freire at NYU Brooklyn Polytechnic, as it used to be called, NYU Poly. And then there are other places where they have this master's program in data science and things like that. And there was even a panel a couple of years ago, I think at Sigmod, where there was talk about if the database guys don't take charge, or more generally computer science guys don't take charge, these other discipline people are now becoming dominant in this data science area. We may be left holding the bag, just like the database people felt left out when the web took off. His previous co-worker, Dave Dewitt, gave a talk on roadkill on the information superhighway or whatever in one of the VLDBs, 94 or something. So similarly, it turns out you don't need to actually pay a lot of money to get access to big data. There are some places where you can get it for free, data.gov and even AWS as public data sets. Of course, you can pay to Twitter to get small amount of data or all their thing. In fact, at Stanford, they were saying they now have access to all of the Twitter data. And of course, we now have a partnership with Twitter, so we have internally access to all the Twitter streams. And then there's also even free GIS data and things like that. So now for the chaos. So even he can't probably read any of this, doesn't matter. So this is like a subway diagram. What is this? This is the so-called data platforms map as of October of last year. This is produced by this outfit called 451 Research. There's a guy by the name Matthew Aslett. He's the guy who's keeping this up to date. Every few months he puts out a new version. So think of it as each subway line is like a type of database system, okay? You really think, ignoring all the details, this number of systems, and by the way, this is not even the complete list, meaning a lot of the research projects are not even here. Some of the research projects are there if they become open source, this, that. So typically these are products or these open source type things. Over the years, as he produced this, he figured out people are curious whether or not their system of interest is there. So he thought it was becoming such a pain to even try to locate. He provided this.
And these are just the platforms.
I don't know what you mean by platform, but
not
it's like
software,
DB2.
for example.
Sorry?
Yeah, but not analytic software.
Yeah. So we'll come to that. We're coming to that. By the way, I'll go into some more details about some of these systems later on. But in terms of the cheat sheet, it's hard to tell here. But it's like general purpose, big tables, graph, document, data grid, search, appliances, new SQL databases, advanced clustering, sharding, in-memory, stream processing, blah, 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 okay? And look at this, I mean, when you see it in this form, it's already filling up a whole page in small font, okay? And it's not even, as I said, complete list, really. I mean, you think this many systems could be fed and cared for, TLC given for them, ad infinitum, no way. I mean, so, okay, so the afternoon talk will get into all this. So there is, by the way, a 2-hour version of my tutorial when I gave it at Technical University of Crete about a year ago. They posted it on YouTube. Okay, you can go look at it if you want. It talks about different types of what I call modern database systems, new SQL, NoSQL, and then what his ex-advisor derisively calls the elephantine systems. They're not just sitting there circa 30, 35 years ago, as he would like you all to believe. They've been evolving also. So you'll hear about DB2 Blue and Hackathon and so on. So all these age-old systems have not been sitting still. We are not stupid to let the money be taken away by these newbies or attempt to be taken away. So we are also enhancing. Even this morning I was on a call on all this DB2 Blue stuff. So we'll hear more about various things. Of course, SAP HANA and Google F1. There were various drivers behind all these modern database system features. We'll get into hardware, software, and organizational kinds of things, like not just money, but control and so on, being able to have access to the source code. Also the evolution of social media and Internet of Things. Nalini was telling me about Internet of Things just a short while ago today. And then there are other criteria like, oh, won't it be nice if I have a single programming language in which I not only mess around with transient data, traditional imperative programming, but also I can mess around with persistent data. Some people think this is like some modern, revolutionary concept. Guess what? There have been conferences forever on this kind of topic called persistent object systems, POS. Malcolm Atkinson and various people have had, also the brown guy, Stan Zadanek and various such people. Even you guys did something along these lines. Yeah, of course, object databases, sure, for sure. Single level store, a whole bunch of concepts. We'll get into all that later. Okay, so now comes your Sharad's question. So, if you thought the previous picture was bad, if you now go one level up and look at the big data landscape, or as it's called big data landscape, and this is the version 3.0, and it's actually fairly out of date. It's May 2014, almost a year old. I haven't looked to see whether there's a more up-to-date version. So, what is the story here? So on the left you have infrastructure, which is pretty much like what was in that previous slide, right? The subway diagram, but presented slightly differently. But it does have some more things, because it has now management and monitoring. It has security. Those things were not called out separately in that previous slide. In addition to, of course, MPP and new SQL, NoSQL, graph database, and so on, which were part of the previous one. And then you have in the middle analytics software. Okay? And then you have on the right 1/3 applications. Okay? Then you have horizontally cross infrastructure, open source, and data sources. Data sources can be pretty varied and could come from various places. You even see Fitbit and things like that over there, right? Yardley is the one that was done by this Venki, the guy that used to be at UC San Diego, who is now in India. This is the one that will take all the information about your different accounts, financial accounts, and consolidate and give you a unified picture of your bank information, credit union, your investments in this and that, and so on. So this again is like crazy. Okay, so what did these guys do? So this was done by this group of people at the bottom, Matt Turk and somebody. They are more like advisors type of people. So what they wanted to examine was, so there is all this hype. Let's see how many of these big data companies have actually had an exit, a successful exit, where a successful exit is you either go public or you are acquired. So it turned out of the 358 companies that they had looked at, only 16 had had exits. And that amounts to like 4.5% overall. Okay? And then they further subdivided them, and so this was the number of companies, and the whole thing is the number of companies, out of which this small fraction are the ones that actually had a successful exit. And so analytics, infrastructure, applications, open source, data sources, and infra/analytics. So the most popular segments within each of these, for analytics it was data visualization and unstructured data. For infrastructure, it was NoSQL and new SQL, not that much of a surprise. And then in applications, it was ad optimization and marketing. So if you want more details, you can look at this picture, and it splits it further. It's somewhat reformulation of the information you saw in that big chart. But it has the number of companies indicated here, whereas there, the logos of the companies was there. Now, if you are the sort of the computer science kind and you don't care for real systems and so on, you can go read this paper. This is the report that came out of this was a CRA one, right? Yeah, CRA, Computer Research Association, or whatever it's called, the heads of computer science departments of the universities and research labs. Jagdish and various people put together this. The reason I'm saying you can't get anything out of it about real systems because they don't mention a single system. It's like a more abstract discussion of what the problems are and so on. So a subset of that report got published in the communications of the ACM, and that's the place from which I extracted this. So just like you talk about life cycle for software, these guys have talked about life cycle for data, okay? And in addition to the usual thing that people have talked about forever in the context of structured data, which is all this extract, transform, load. They talk a bit more about other things also here, like data integration, aggregation, representation, modeling and analysis, interpretation also, right? Because the data are coming from all sorts of random sources. Even things like, the sorts of things that Yahoo and so on had to do in Yahoo Travel, or even, what is the one that tells you about restaurants? Yelp and so on. Life gets complicated for them, right? Because they might read reviews about a restaurant, and they have to realize that, oh, it's the same restaurant, but the name had changed. So what appears to be reviews about two different restaurants is actually a review about the same restaurant. All sorts of stuff like that they have to worry about. And also they have to, just like in the Wikipedia, you can't assume everything that's there on the web must be true, because you know that people do all sorts of silly stuff. Even my kids' high school, they went and did some fooling around for some play or whatever they did by making me the father of the famous Parthiv Mohan, or whatever is what they did. And they even showed it in the auditorium, in the school. Dumb things like that also people do. And sometimes it's mistakes, right? So there's all sorts of stuff that happens. So they talk about phases in the big data lifecycle, and then they talk about challenges in big data analysis, okay? And so even visualization and collaboration and all that have become very important. So we've talked about this already, so let me not dwell on it. And you have seen, I'm sure, the evolution of, from Hadoop 1.0 to Hadoop 2.0, what happened. They had to worry about, all this deployment, tooling support, a real, scheduler and things like that, Yarn and so on. Okay. So we've sort of also gone up the stack by not just focusing on fast data and analytics, but even focused services, which have to do with specific areas, which is like the kinds of applications I listed at the beginning. Big SQL 3.0, you heard about this. There are various attempts at trying to marry Hadoop way of doing things with the traditional parallel database way of doing things. There are various attempts being made. This is one attempt done at Almaden and commercialized via a product organization. But something like Hadapt at Yale was a different way of doing things, where they stored the data in PostgreSQL, but then they made use of Hadoop as the parallelization engine, whereas we do just the opposite, right? We are using DB2 as the parallelization engine, but the data itself is coming from HDFS and so on. This is one thing I have to talk about. I mean, these Google guys, they did their thing 7 years ago, whenever, and then they let the whole world go crazy with this stuff. And then they wait till about a year ago, at the I/O conference last year, some senior fellow comes and says, ha ha ha, this stuff doesn't really work. So we gave up on it a long time ago. We don't really use, he literally said that. I wasn't there, but this is what I have read. And then he says, okay, here is a bit of news about what we do, but he didn't reveal the whole story. I mean, as computer scientists and so on, how fair is this that they don't let some reality be infused into the discussion when the rest of the world, including Jeff Ullman, all sorts of people, have started conferences, workshops, this, that, and gazillion PhD theses. Of course, it's a hallelujah for writing papers and producing theses and so on, but at the same time, you also want to do stuff that's of some long-term value and is not of some short-term interest. But then they did all this in the context of announcing what they called Google Cloud Data Flow Services. Maybe if they were not doing that, they wouldn't even have bothered to do it even last year. But anyone who had some background, when they looked at, oh, after every step you write the data to disk and then you read it in the next step, and in the process of doing all this you do serialization, deserialization. I mean, are you crazy? And then somebody comes and says, oh, why not feed the output of the first step as the input to the second step? Wow, suddenly they discover pipeline. And then, people say, oh, great idea. Come on. So this is too much for me to handle. Even if I'm old and all that, that's still not a justification for the youngsters to think they can get away with murder like this. Just do some homework, please. Don't just think that you know everything and just cook up something on the fly and think that as time comes, we fix things, keep it, all this KISS kind of principle taken to the limit. Keep it simple and stupid. I think I need only this level of functionality. I'll do something extremely tailored for that. And as requirements change, if they change, I'll deal with it as it comes along. But the initial thing that you do might not have enough of extensibility built into it. So it might be a patch after patch, and that's the problem with this way of doing it. So this goes more into the kind of analytics stuff that's gone on in Almaden. What sort of analytics, text analytics, entity resolution, machine learning, need to operate in different environments near real time. So now you hear a lot about this, stream way of doing things, Kafka, this, that. There's a whole bunch of even startups coming up. Junrao, I noticed, is now part of a startup that has been spun out of whatever from LinkedIn that has something to do with this real-time stuff. Of course, this was a major criticism of MapReduce, right? That it's only for batch-oriented stuff, and that's not good enough. What a surprise. Did somebody have to really, think a lot to do a Wisconsin-style graph and this and that to discover this? I'm not sure. Need to be tuned for individual solution domains. Even things like a water index that was developed was a non-trivial effort at IBM, and this was done even before this latest water crisis in California. They wanted to treat water like a commodity and come up with an index and try to, figure out what the real cost of water is and things like that. So I'll skip through these things just to let you know that these are the things that are there in the slides. System ML. So what IBM research guys originally did, while in parallel, Stonebreaker and company did it at Ingress at Berkeley, for structured data has been now done for text data, that is having high-level query languages, and then letting the optimizer of the system do the translation from the high-level spec to the actual execution plan and so on. Pretty similar stuff. They also have the same sort of notion like QGM, where query rewrite is done without cost basis but rules of thumb kind of thing. And then you have a cost-based optimization step, similar stuff. Stratosphere, this is the project I mentioned already, Apache Flink. Their attempt was to do all this, support different types of environments, Java, API, Scala, Sparkle, and so on. Also operate on this base of a cluster manager that might be yarn-based, or it may even be on EC2. Yeah, okay. So I'll just let you go through these things if you're interested, and I have one slide on your thing. I'll find out more.
Didn't mean to rush you through that.
Yeah. Okay, look at this. Hortonworks. It's all nice, right? I mean, we've gone through this long ago. If you remember DCE and Transarc and all these guys, it was all cool at one time to talk about distributed computing environment. Take components developed independently by different groups, slap them together, and you get all this nice componentization, modularity, blah, blah, blah. When it came to performance, story was very different. It was not really good enough. And look at the number of components that are being slapped together, and how many different versions of these things exist. This is one of the reasons why some of these companies that are pretty much completely open source, as Hortonworks is, still makes money, or hope to make money. Because they feel that for the mere mortals to figure out which version of which of these constituent middleware, whatever you call them, components, will work correctly at all, if at all, will work at all correctly and then with good performance and so on. So they come up with different releases of their distribution where they have carefully tested and made sure that things work reasonably well, whatever. So this is a non-trivial task. Storage. So there are all these references. There are actually much more I could have talked about. AWS, for instance, they've got their own thing called the Elastic MapReduce, which runs only on Amazon Web Services. If you want a private cloud version, then you have to go with, they support, I believe, Hortonworks as their official thing. Oh no, sorry, MapR. MapR is what they support. But if you want to use anything else on AWS, it's all up to you to do the management and this and that. They don't provide native support for any other Hadoop platform that runs on AWS. They also have their own different database systems and such being supported by Elastic MapReduce, DynamoDB, this, that. Quite a few of them are there, including Redshift, which is their data warehousing platform, which is like a MPP SQL system, and on and on. I'll stop here. So there's all this Storm and Spark is all, you know, currently the hottest thing on earth and so on, and it's only in memory. And even I really deal with this and things like that. So.
I think we have time for like 1 or 2 questions, and then we'll let people go.
Or everybody is hungry. Yeah.
So Mohan,
yeah.
I was confused to begin with, and now I'm more confused.
Good. I'm glad. That is the idea.
I guess the question is, you are addressing an academic community.
Right.
What should they be doing? Where do you think the action is? Like, should they be looking in frameworks? Should they be looking in analytical software? Should they look in application space? What do you think we can contribute?
So you can at least do the you know, longer term kind of thinking. You can do the longer term thinking, and you know, instead of joining the fray, you know, beat them up and make them see the silliness of some of the things that have gone on. People could have questioned a lot more, for instance, the MapReduce stuff before they widely adopted it. I mean, so many of the things that have been done, it's not like they haven't been tried out before. Many things, like even invoking programs willy-nilly in parallel, this, that. People did that with user-defined functions and such, right? User-defined even aggregates and so on. Why didn't those things really take off even in a traditional database context? Because they became hard to model as part of the query optimizer. What's the selectivity of a user-defined function? And what's the cost of executing those things? Many such things have been explored in the context of Postgres and things like that, right? Now, by dumping more of the problem in the hands of the users, by not necessarily supporting higher level query languages, now people think somehow that lets them happily re-enter the arenas which had been explored but not fully supported. Or people said, oh God, there are too many difficult things to do here, let me not push this too much. So my request to you guys will be, and I've heard this coming from many academicians, they don't know exactly what they should be teaching. In fact, somebody asked me, should we still be teaching traditional database concepts, or should I now say dump all that old stuff that even Raghu's of the world, when he gave a keynote in Singapore or somewhere, was like talking about all this new stuff.
Oh, he was wrong. He was plain wrong.
Yeah, but he did that, right? I mean, he had written a book, but then he came and talked about all this Yahoo kind of stuff as if, you know, that's the only thing that matters, without putting any caveats around it. So you should at least make sure that when people go out of the university, that they have a sense of balance about what are the real things that need to be worried about, and not be too narrowly focused on. See, the other way of saying this is, I tell people, and this is the point I made when Raghu gave that talk, I said, look, I can't build a business case around the requirements of the Web 2.0 guys, because they are not buying my hardware or software. If I'm an IBMer, and I'm trying to justify building something for the Web 2.0 requirements, unless I see them spending money on my thing, I cannot build a business case. Yeah, as a techie guy, I can go off the deep end and do all sorts of stuff. But even when I do those things, I would rather do something that's of some real practical consequence rather than of some niche interest. So it's this battle between worrying about niche interests versus broad-based interests or requirements, whatever you want to say, is one of the things. And where do you think there are interesting problems to solve? If you have a choice, you should really go for the one that has wider applicability than very narrow applicability. Yeah, there are any number of interesting problems at the higher levels. It's at certain level, from the middleware down, that we have a problem with some of the craziness that's come about. And don't give up on this notion of at some degree of standardization and all that is a good thing. Software engineering principles don't just go away because you have vast amounts of data, this or that. And you can't just sustain this many of these variety of systems. So.
Great. Thank you very much.
Okay.